Bismillahirrahmanirrahim. Exercise 3.4, question number 1, part 12, integral x cube cos x dx. The formula for integration by parts is integral f of x gx dx, considering fx as the first function and gx as the second function. It is equal to first function constant integral of second minus integral derivative of first function into the same integral. The previous knowledge which we must have here is these are all very simple results. Integral of cos x dx equals to sin x plus c. Integral of sin x dx equals to minus cos x plus c. And derivative of x cube is 3x square, of x square is 2x, and of x is 1. Now let's start integration. Let's start the solution. We name the integral as I. We are considering x cube as the first function and cos x as the second function. So let's start integration. We are going to integrate by parts, and let's see what do we get. Integral I becomes first function constant, integral of second minus integral bracket starts derivative of first function, that is d by dx of x cube into the same integral cos x dx bracket close, and we have a dx here. Now you may write these results with the help of this revision, or you may write them if you have learned them. So x cube integral of cos x dx becomes sin x minus integral derivative of x cube becomes 3x square, and integral of cos x dx is again sin x and then dx. And you know that we are not going to use constants of integrations, because we use constant of integration only when we perform the last integral. So let's see, we get x cube sin x, take 3 outside the integral, and you will have x square sin x dx here. Now just see, I'm going to write it like this: x cube sin x minus 3 into I1, where this I1 is equal to integral x square sin x dx, and we name this result as result number 1 for further reference. Okay, now let's get to our integral. Integral I1 is this. We are going to perform integration by parts again, and we will consider x square as our first function and sin x as our second function. Let's perform integration by parts again. I'm going to write integrate by parts. And what do I get? I get I1 is equal to first function constant integral of second minus integral bracket starts derivative of first function, that is d by dx of x square, into the same integral. And what is the integral? Integral sin x dx bracket close, and we have a dx. So you can write these results with the help of these, and we get x square minus cos x minus integral 2x, and then again minus cos x and dx, because integral of sin x dx is minus cos x, integral of sin x dx is minus cos x, d by dx of x square is 2x. And we have not used constants of integrations because we still have to do more integrations here. So this becomes minus x square cos x, bring this minus into 2 outside, so it becomes plus 2, minus minus becomes plus, and this 2 outside, and we have x cos x dx. Now let's see, I'm going to name this as integral I1 is equal to minus x square cos x plus 2 into I2 and name this result as result number 2. And what is I2? Where I2 is equal to integral x cos x dx. Again, we are going to perform integration by parts with it and using this is the first function and this is the second function. So what do I get? I'm going to integrate by parts, and what will I get? Integral I2 is equal to first function constant, integral of second minus integral derivative of first function d by dx of x into the same integral cos x dx, all this inside a bracket, and then we have a dx. First function constant, integral of second minus integral derivative of first function and the same integral and then a dx. Again, you can use this sidebar and write these results and you will get x into sin x minus d by dx of x is 1 and integral of cos x is sin x dx. Now what do I see? X sin x minus sin x dx. This is it. And now we are going to write the result of this integral, and you can see this is the last integral. So now we are going to use constant of integration. So we get x sin x minus bracket starts minus cos x plus c, open up the bracket, x sin x, we better use c1, and x sin x plus cos x minus c1. Put this result, put it, we must write put it in result number 2, the value of I2 in result number 2. Let's put this result in result number 2, put the value of I2 in result number 2. Where is result number 2? Here it is. So we get integral I1 is equal to minus x square cos x plus 2 times x sin x plus cos x minus c1. You may open up this bracket and you will get minus x square cos x plus 2x sin x plus 2 cos x minus 2 c1. This is the value of I1. Now what? Put this result in result number 1. So what you will get? You will get I is equal to, this is result number 1, it is equal to x cube sin x minus 3 into I1. So this is the value of I1. So it gets minus x square cos x plus 2x sin x plus 2 cos x minus 2 c1. Open up the bracket, you will get x cube sin x plus 3 x square cos x minus 6x sin x minus 6 cos x and minus 3 into minus 2 plus 6 c1. Now what we are going to do? We are going to put this 6 c1 equals to c. Put 6 c1 equals to c, and we are going to collect these terms. Which terms? We are going to collect these two, x cube sin x and minus 6x sin x. We are going to write these two terms together and we are going to take sin x common, and then we are going to write these two terms together, 3x square cos x and minus 6 cos x, and we are going to take cos x common. Let's write the result now, and we get integral I is equal to x cube sin x minus 6x sin x. We have to take sin x common, so we get x cube minus 6x inside the bracket and sin x outside, then plus 3x square cos x minus 6 cos x. So what do we get? We get 3x square minus 6 inside the bracket and cos x outside the bracket, and in place of 6c1 we are going to write c, and this is our answer.